Yeah, good afternoon. My name is Matt Stephenson. I work at Starburst. Yes. I do a lot of infrastructure stuff there, if the Burning Man hat didn't give that away already. Today I'd like to talk a lot about what kind of changes we've done to Trino over the last, actually a few years now, to make it more operable, more observable, to improve its ability to be operated in production. So I'll cover just kind of a little bit about what OpenMetrics is, what OpenTelemetry is, and a little bit into some of the changes we made to the Airlift logging system. Kind of talk a little bit about how we deploy software at Starburst, and give a little bit of an example of that. Unfortunately, I won't get to all of the bullet points there. I'm kind of pinch hitting here a little bit for another speaker, and what you're seeing today, the content was developed in about 1 day. So we will not get to the logging component. I've got a little bit of metrics to show you. But I definitely can, everyone can walk away with the ability to deploy Trino on Kubernetes with Jaeger for tracing. So what is OpenMetrics? OpenMetrics is an open standard for pull metrics. It's it's a format that supports really complex data structures like histograms and data and summaries and such, so that you can do you can easily expose percentiles and quantiles. It's originally from the Prometheus project, but it was adapted to be more of an open standard. We added support and Airlift to it. Any Airlift app, including Trino, just has to instantiate the JMX OpenMetrics module, and it'll automatically expose everything on the /metrics endpoint. There's no real configuration necessary. It utilizes JMX utils, which Martine wrote originally. I've made a few changes to it to make it a little bit to support more of the OpenMetrics standard. There's some changes that I'd like to continue to make on that, so keep an eye on that repo if you're going to use it for anything outside of Trino, because we use it for all the services inside of Starburst, not just Trino, to do all of our metrics. This is exactly, we basically build software inside Starburst the same way as open source Trino from an operations perspective. But some of those changes I think that I'll be making in the near future are going to be to, instead of relying on JMX as the underlying store, we'll use OpenTelemetry SDK as the underlying store. So it'll allow things like dynamic labeling. OpenTelemetry is, of course, an open standard for traces, metrics, and logs and events. Something to note, OpenMetrics is it's fully adopted by OpenTelemetry. There's a whole lot of camaraderie between the two standards, between the two projects. So they kind of just seem like the same these days. The support for metrics and OpenTelemetry is push, not pull. That's probably the most important difference between the projects. We use OpenTelemetry and Trino primarily for traces. But like I said, we'll probably start using the underlying SDK for metrics as well. And we're investigating using it for some of the logging as well. So I think it's a really great standard. I suggest people take a look. It uses gRPC for the push protocol. It has a really broad ecosystem. It's really easy to tie it into Jaeger for tracing, Datadog for tracing logs or metrics. All of that's just configurable within the collector. So I'll walk through a little bit about how that works in a few slides. We added support for it to Airlift. You can instantiate the OpenTelemetry module if you build any service based on Airlift to get it. And you can just, then from there, you're basically using the open source OpenTelemetry SDK. There's no additional SDK, APIs we built on top of that. To use it in Trino, of course, you just set tracing enabled equals true and point it to a gRPC endpoint, which I actually had a lot of challenges doing when I was setting up the demo for this. Airlift logging, it's a pretty, I think Airlift logging started writing 15 years ago. So it's been there for a while. It's all built on top of Java util logging. It's super simple, straightforward API. We've added support recently for, instead of logging to a file, you log through a TCP channel, which this makes it really easy to integrate it with FluentBit or the OpenTelemetry collector. And the OpenTelemetry contrib collector repo, there's, and hopefully in the example repo pretty soon that I've got that I'll show later today, there'll be some examples of how to basically use just the OpenTelemetry collector by itself to act as a TCP receiver for the logs and be able to do parsing and annotating and adding additional fields. One of the neat things is we added this node annotations file. I'd suggest if you want to, like, for your own operations internally, take a look at that. One of the neat things you can do with that is that it supports basically that property. If you add it to config.properties, you can add in another file. That references another file. And that file is, of course, property file, key value pairs. And in the values, you can do interpolation from environment variables. So one of the neat things you can do is you can take like standard environment variables that come in to the container in Kubernetes and just expose those as additional structured fields in your logs. So let's say you want to know what your host IP is, your pod name, whatever. You just include those directly into the log lines. You don't have to add a bunch of, we have some pretty complex FluentBit config because we still have a little bit of that in there. You can just directly add those static fields in there and kind of skip a lot of the additional infrastructure overhead. To basically any log file that you can set through Airlift will accept just setting TCP as a protocol and the IP import, and it'll start working. If you find somewhere where it doesn't work for that, let me know and I'll fix it. So this is what I was hoping to do today, but I didn't quite get to all of it. Basically getting an ingress controller, Trino coordinator, and Trino worker. This is kind of like pretty much how the open source Trino Helm chart can deploy things. And then adding on to that, an OpenTelemetry collector that collects both, collects logs, metrics, and traces from all three of those components, and then pushes those down to Jaeger, Amazon Managed Prometheus, and OpenSearch. The OpenSearch definitely isn't there. Amazon Managed Prometheus, I think me and Vinay will probably hack that out by the end of the day. So by the time you actually get a chance to pull up the example repo, we'll probably have some good example code in there for you. And then, of course, bolting Grafana on top of Prometheus, which you can actually also use Grafana to do some interesting stuff with events through OpenSearch. So hopefully we'll be able to get some more of that demo up for you all in the near future. So yeah, let me just kind of walk through some stuff. So this is the repo. Let's see. I am doing this on an iPad, so I've never done this before, but let's try it. We'll pop over here. Let's see if that comes up appropriately. Great, but it's really tiny. Yep, not able to zoom it too well. Let's full screen it. Can you all read some of that? I'll just talk through it a bit. Command plus. No. Yeah, I guess GitHub doesn't quite, the GitHub app doesn't quite support it. It's fine. Well, I'll just walk through it a bit. So basically, the way that Pulumi works is it's, if anyone's used Terraform, it's really similar, but you can work in like a natural language. So since probably everybody in the room, in this room is comfortable in Java, we chose to use Java. The way that you tie it in is you basically have a plumi.yaml file, which has just a really simple reference, just like a name, and just saying that this is Java. And then you just define a main class in your POM file, and Pulumi will actually go on ahead and execute Maven for you. But do the whole Maven build, and then kick off your provisioning through this main class. So if you go through the source, take a look. It's a really simple class, what you end up with to start off. You're basically just kind of like going to have this main method that's just going to kick off Pulumi run, and the Trino cluster new is actually just a pojo. There's nothing really special about this class, but let's just walk through it real quick. So I'm using a lot of like little shorthand stuff in Pulumi, which makes it really super fast. So line 41 right here, VPC, VPC new, VPC, that is actually going to do that's going to spin up an entire, what's that? No, it doesn't. No, yeah. I think it's the app just doesn't support it. But basically, if you go through, if you run just this new VPC, Trino demo, it's actually going to spin up like it's going to spin up a VPC in AWS with 3 subnets, with 3 NAT gateways on it, and actually 3 private subnets, 3 public subnets, 3 NAT gateways on it, and it'll just do all that in one line of code, which is great. You can configure you configure it to very like extreme amounts, but you know, it's nice and simple and concise. The cluster component there spins up the EKS cluster. You can kind of give it the type of nodes you want. We're running on T4G extra larges. That's actually like one of the nodes I found that's like super cheap and great for running Trino. So, and then it just kind of installs right here, Trino demo. This creates the Kubernetes provider. The tracing config you can see here, if it's zoomed in enough, it's clear enough. That's actually really similar to what I have on the slide there. That just points it over to the Jaeger instance that I'm spinning up. Then I install the Trino Helm release, which is documented on the open source Trino website. Install and configure Jaeger. And then install and configure OpenTelemetry collector, which is just a bit of a monster. And this chunk of the code will probably grow pretty substantially. Of course, like, reach out to me if you have questions about any of this as it evolves. Hopefully, we'll just keep this like up to date with all like the neat open source observability stuff we're building into this. So one of the cool things that you get out of using Pulumi, and now, yeah, this is actually going to be able to zoom in pretty well. So cool. So this is actually, I'm going to zoom it out so it's really hard to see again, since you're all used to that. This is all of the resources that are being deployed by Pulumi into AWS through that little chunk of code. You've got the main stack reference, and then here you've got a couple Helm charts, the EKS cluster itself, and then it has all of its dependencies like setting up all of the EC2 security groups, setting up the service role, setting up all of the various policies, role policies and such, so that the nodes can, you know, talk, like EKS nodes have to talk to various services inside of AWS to be able to do just about anything, especially like if you've ever looked deep into a Kubernetes cluster, you'll see like there's all these daemon sets and additional pods running that are doing all of the work to like attach and deattach storage and such. So that's what all of those roles are for. Here's all of the VPC. Like I said, that was one line of code, right? So this is that one line of code, and then bam, it's built all that infrastructure for you. So yeah, that's how we do most of our deployments of services inside Starburst. And if you have questions about this example code base at any point in time, let me know. So what we ended up with was, and you're welcome to like send queries to this thing. I added my own DNS on it so it's easier, but there's Trino up and running. I'll just refresh it, and then yeah, it still works great. Awesome. And here's a Jaeger UI. You can already see that there's a couple traces that have popped along. If anyone's not played with the Jaeger stuff that's in some of the development environment for Trino now, I highly suggest it. The Jaeger that this example actually installs has like a full backend storage on Cassandra and such. So it's like kind of the industrial strength Jaeger versus the running it in a Docker container all in one. So let's see, maybe that looks like a beefier one. That's a little one, but yeah, so it's just like doing some access control checks. This is probably me clicking around in the UI at some point. But yeah, I would highly suggest doing this. Of course, a lot of folks are familiar with Prometheus. This is kind of an example of Amazon managed Prometheus and Grafana. This is just some of our like dev work at Starburst. I don't have a good example of Kibana right now. we do, instead of integrating all of this internally at Starburst, instead of integrating this with, say, Jaeger and Prometheus and Grafana, we actually internally integrate it with Datadog. Everything just goes over to Datadog. And it actually, since at its core, we're just changing this, gunk of config here to be able to point it to different things. In fact, like, you basically set up different receivers, and you point those different you basically have pipelines. So say I wanted to also send this to like Datadog, I would just add to this immutable list here of exporters, like Datadog. We've experimented with a whole bunch of, it's like the flexibility of using OpenTelemetry in the middle. The OpenTelemetry collector in the middle has made it so we can just kind of experiment with various metrics vendors, various tracing vendors, log vendors, things like that. Some of the other really neat things that we're experimenting with, and I think we'll see more of in Trino, is the ability to do like processing of events. So you get much more rich event data off of like directly out of the OpenTelemetry traces and such. So in the OpenTelemetry SDK, you can attach events to spans. We're using that in a couple places where we say we're processing some amount of data for a customer, and we want to like say, oh, within this context, we've processed 800 gigabytes or whatever, right? So we create an event with kind of that rich data in the event so that we can process those events. Since in like the context of a customer using something or like a query running, you don't really want to necessarily have time series data there, like say what you would put in Prometheus or expose with OpenMetrics, since it's very ephemeral contexted data. Awesome. Let's see. So yeah, I think I only have one more slide. Yep, that's it. Cool. Thank you very much. And Dane.
Do you have a full query in your demo?
I don't have a full query.
Well, then do you want to speak to what's in it? Because I think it's pretty extensive what the tracing does nowadays.
Yeah, I don't have the Trino client on my iPad, but does anyone want to send a query to it? Like, it's open on the internet. There it is. There it is. It's just Trino demo, step arrow, 8080. Any takers? Yes.
So we're using OpenTelemetry in-house, like what you guys built, and it's pretty awesome. Also to the extent, like sometimes it generates.
Do you want to do the mic?
Too many.
Oh, this is a
Just
really
for
good
the
question.
online folks, sorry. Make sure we get your good question.
Yeah.
I'll let you
So
repeat
this
it.
is pretty awesome, like all the tracing with OpenTelemetry. I was just wondering, like, is there any way to control the data, or what are different mechanisms you can control the data?
Yeah.
Which is basically generated.
Yeah, that's excellent feedback. I can actually put that into that demo repo that's on my GitHub. But what you can do is you can have span processor. You can do span processing within the OpenTelemetry collector to filter out spans that are too noisy. Or you can do it, say, in like a lot of the observability vendors. So Datadog supports that. You can just say like, don't index anything that's less than like a certain duration or is of a certain named trace. So all of that's possible both in say like Datadog as well as in like the OpenTelemetry collector processors.
Yeah, to add to that, there's still work we have to do there. Being able to control tracing on a per query basis, being able to constrain the spans that get logged to some parts of the query. For example, you may be interested in how this query relates to or interacts with the access control system, but not the execution side. So being able to control that. So still like stuff we need to do, but
Yeah.
Right.
Yeah,
Yeah.
also just as an update on the Trino Gateway project, we're also working towards integrating OpenTelemetry. So over time, you'll be able to even trace through that. And then we'll have the same sort of thing where you want to limit what you're actually collecting.
There's a lot you can do in OpenTelemetry as well with the trace context headers. And so we're investigating that and seeing what we can do there, right? So we can say like, don't bother tracing if someone like stopped. Like if you have a query, if when you submit the query to the coordinator and you start farming work out to the workers, if the tracing was disabled on the initial submission, of course, don't do anything downstream. Oh, it looks like someone ran something.
Well, someone ran some queries, so we should look at those. But we've also been talking about maybe having like session properties to say like, for this query, please really, really trace everything in detail because I'm trying to figure out what went wrong. So like possibly give a hint to the source when you submit the query that this is something important, let's trace it and let's keep it somewhere else. Like we literally like, I think almost all this tracing stuff has gone in the past 6 months, Matt.
Yeah.
And like David and I and some others went through and just added tracing like everywhere. It's so useful. Like we found a ton of bugs by just like looking at the traces and going, what the heck is this? Like it's pretty awesome.
There's a question from Eric behind you.
I need to drill down on this sampling because on a large query, you can have 70,000 spans. I mean, it's chatty as hell.
Yeah.
And we've been looking at needing tail sampling, kind of what Dane was hinting at of, oh, there's a problem. We need that whole log. So
Yeah.
however we can work together to come up with that, because it's an amazing way of troubleshooting. But one other thing people are missing too is all these event listeners and stuff you're building, why the hell would you do that? Why wouldn't you just put it as a no-tell collector and sample your events outside of Trino in another system?
Yeah, that's what we're actually starting to do on some internal services, Starburst too. It's interesting. It's really shifted that. There isn't, unfortunately, there are some places where OpenTelemetry events can be lost with the current protocols. Like, I think that, and with the current collector, I think we'll probably contribute some work pretty soon though to kind of make things a little more durable. On the tail sampling, the problem with that, of course, is that you know, at really high, so you can do that in an OpenTelemetry collector, but you're going to end up having to spend a lot of memory to do it because you're storing a bunch of those, that full set of trace, all those spans for one single trace. Right there in memory, and then shipping it out once you close it out. So we're looking into how to do that. Of course, you know, obviously with that kind of, if you want to do something like that with OpenTelemetry, you have to deploy it kind of like as a daemon set, so that you're running it on every node. You got as much memory as possible. So.
Not part of this, but I see on your first tab there, this is called auto scaling. How do you deal with the auto scaling in Kubernetes with Trino?
So we have really complex auto scaling internally in Galaxy for Trino. So it's like, it's very custom. It doesn't really tie into the observability stack, but we expose a lot of metrics and traces and stuff that let us debug things when they go wrong.
Yeah, you should open source that.
Related to that, and also totally shameless plug, in the Trino community broadcast episodes recently, we had someone that implemented some auto-scaling based on memory. The default auto-scaling obviously is just on processor like load in Trino. And also we, in the Trino community broadcast in the past, I don't know, like 3 or 4 months ago, we had actually Matt join us and David, and we had a demo and all that. So that part is documenting. So if you, and in the Trino docs, so if you want to play around with that, that's pretty easy. And there's like steps on how to fire it up with Docker Compose, which is a bit like Docker itself. It's a bit easier than the whole Kubernetes stack, but that can get you started. And I'm still working towards the docs for open metrics and log formats and that kind of stuff. So if you're looking for that documentation, you need to look at the active PR that I'm like owing everyone to finish. I don't know if anyone fired a query into it, so
they did. Here it is.
Oh, thank you very much to whoever shot that in. That's great. So let's have a demo.
It took a whole 430 milliseconds, and it'll take us way longer than that to look at this. So yeah, there's a. I mean, of course, you know, access control checks, tons of metadata, getting metadata. Yeah, actually, since this is in Chrome, I can expand that. There we go. So yeah, lots of query optimizer stuff. And you really see like, yeah. Yeah. So you can see all of them. Optimizer rules. And of course, like if you look at the trace, like if you just thumb through like one of these traces, you'll notice that everything's like there's so many traces that are less than 1 millisecond. We really like the thing that we really did to reduce our trace load in Datadog was just say, you know, unless we are allow listing specific clusters or customers, just don't even index or retain any traces that are less than 1 millisecond. We're working on building a little bit of infrastructure around the OpenTelemetry collectors to make it so that we can dynamically update those to say like, you know, on the fly, like we have a customer that's like, you know, they ran a query we never did, right? And got a result we never really expected. But we can pretty easily turn on tracing and improve their logging and things like that. So, yeah.
Okay, any questions in the audience or online otherwise? All right, well, it looks like we are closing the session. Thank you so much, Matt.
Yeah.